have another here question now. It says a container holds a mixture of hydrogen and oxygen in thermal equilibrium. Now, from this statement that in thermal equilibrium, that means we know the temperature of everything inside the container is going to be the same. So they are both at the same temperature, and the temperature given here is 400 Kelvin. Now, the mass of hydrogen molecule is 3.34 times 10 to the power 27 minus 27 kilogram. Now, given that it's only the translational motions of the molecules that are important here. Now, find the root mean squared speed of oxygen molecule if an oxygen molecule is 16 times more massive than an hydrogen molecule. Now, from here, we're just asked to calculate the root mean squared speed of an oxygen molecule. Now, here we're giving we're giving the mass of hydrogen, not the mass of oxygen. But now we're also given that the mass of oxygen is 16 times more massive. No, therefore we know that the mass. So the mass of an oxygen molecule. So from here we're given the mass of hydrogen to be 3.34 times 10 to the power minus 27 kilogram. But we're not given the mass of oxygen. But note, we are asked to calculate the speed, the root mean squared speed of oxygen molecule. But we're told that the mass of an oxygen molecule is 16 times more massive. That means more heavier than that of an hydrogen. So from here we automatically know let MO be the mass of oxygen is equal to 16 times mH. Therefore, mass of oxygen of an oxygen molecule is 16 times 3.34 times 10 to the power minus 27 kg. We have this. Also, we are given the temperature. Since we are given one temperature, we know it's at thermal equilibrium. So every molecule inside the container is what? At 400 Kelvin. So this is close to. So, but we have now the formula for calculating root mean speed. Root mean squared speed is given by V equals to 3 over n, where n is number of moles, R is the gas constant, C is now, take note, T here should always be in Kelvin because it's the absolute temperature. If you are giving in Celsius here, you have to convert to Kelvin, and that's just adding 273.15 to the Celsius value to get the Kelvin value. Now times divided by the mass. Now take note, this mass here is the mass of the molecules in the container, but we don't have the mass because we don't have the. Now from here, when this question we don't have the mass, but where we're given the mass of a molecule. Now from we know different gas relationships, so we can actually find a way to come around this obstacle here and get something that will give us from what we are given from here. Now, but we know that from here, from chemistry, we know that M equals to N times molar mass, right? The mass of the substance or in a container is mass times number of molar times number of moles times molar mass. So from here, putting this into this, we have that what V equals to so V equals to root 3 nRT over nm, which is molar mass here. From here, this cancels this. But still, we don't have the molar mass of oxygen. We were not given here. We are only given the mass of a molecule. Now, from chemistry also, we know that the molar mass of a substance is what? M equals to the number. Now, the molar mass of a substance is given by what? The mass of the molecule times the number of particles in one molecule and 1 mole of that substance, and the number of particles in 1 mole of a substance is what? Is Avogadro's number. That's 6.02 times 10 to the power 23. Those are the number of molecules in 1 mole of a substance. So from here, therefore, 1 mole, that means 1 mole, and that's the molar mass of a mole, is given by what? Na, which is the Avogadro's number, times m. Now this is small letter m, and this m here represents what? The mass of the molecule. Now putting this here also, we get that what? This is equals to equals to root 3 RT over NaM. Now also, it depends on the question. You might be given now from here, please take it from here. This is Boltzmann's constant. Boltzmann's constant K is equals to R over Na. So Boltzmann's constant is what? Is gas constant divided by the Avogadro's number. So you might be given this or this. Now if you're not given either, if you are given, it depends on what you are given. Like they will give you some constants at the top of your question. Now if you are not given KB, so and you're given R, what you can just do is that know that this, we all know this is 8.314, and this should be what, 6.00 times 10 power 7. Sorry, times 10 power 23. So imputing all this into this question, we get what? V. We get V. So we get V by equals to root. So let me just clean it over here and just write so for easy. Now so we get V by equals to root 3 times 8.314 times 400 over 6.022 times 10 is power 23 times, and from here we have a mass of the molecule of oxygen, that was 16 times 3.34 times 10 is power minus 27. So imputing this in your calculator, you get, so in your imputing this in our calculator, we get what? Roots. So we get 3 times 8.314 times 400. So we get what? From here we can see that this is 556.7. So that's what. So this is, so V from here is equals to 556.8 meters per second. Now from our option we are given what? Now our option states that A is what? 430 meters per second square. Now that's absolutely far from it. This is what? 272 meters per second square. Sorry, per second. Now that's not really close to it. That's not close to it at all. Now from here, C is what? 445 meters per second. That's not it. So from here, if we approximate this to the nearest whole number, this would be what? 557 meters per second. So automatically we know from here that B is our answer. Thank you.